Okay, this is the P3 paper from January 2024. It's question number 6, and as you can see, as I pan down here, it's going to be a mixture of trigonometry. We're going to be solving trig equations, but also we're going to be differentiating those equations. So a bit of differentiation and a bit of trig, both in the same question. It's quite long, so let's make a start to it. It says, we've got the graph that we can see there. We can see points P, Q and R are highlighted. Let's just have a look at part A. Part A says the curve intersects the x-axis at point R. Can we state the coordinates of R? So obviously we can see that that point there is going to be when fx equals 0. So that's what I'm going to do for the first part. So A, our fx is given by, fx is equal to 2e to the to the 3 sine x cos x, and we are going to put that equal to 0. So we either get 2e to the 3 sine x equals 0 or cos x equals 0, and this leads to no solutions. Just think really quickly, don't spend any time on it, but what e to the x looks like. E to the x looks something like that, and it has an asymptote on the x-axis. So that can't possibly be equal to 0. So it just means that we get cos x equals 0. So if cos x is equal to 0, you can do that again from a quick sketch. When is cos equal to 0? Cos looks like that, doesn't it? And these values here are pi over 2 and 3 pi over 2. I'm not going to include any of that in the work. We're just going to say x equals pi over 2 or 3 pi over 2. And then if we look from our graph here, we can see that this is in the range 0 to x to 2 pi. And we can see that it's going to be the bigger of those two values then. So x is going to be equal to 3 pi over 2, which means, and again, we can say that from the graph. From graph, x is equal to 3 pi over 2, so point R is 3 pi over 2, comma 0. If we look, there were two possibilities for when we could get our R, and so it was the second one of them. Okay, on to part B then. It says the curve has two turning points, P and Q, also shown in the diagram. Yeah, I can see those. Can we show that at those points we get this quadratic? A sine squared x plus b sine x plus c equals 0, and then see if we can find those. Yeah, so what are they asking us here? What they're basically expecting us to say is that at turning points, f dash x is going to be equal to 0. So we'll do that. We'll go through the whole process of it. So remember, what did we have fx being? Fx was 2e to the 3 sine x cos x, and I want to work out f dash x. Well, if I want to work out, excuse me, f dash x from that, I'm going to need to use the product rule. Let's just move this all over a little bit because I need space for my product rule. So what I always do, the product rule, write down what u is, 2e to the 3 sine x, write down what v is, cos x, differentiate both of these now, and I always lay it out in the same format here. Differential of cos is minus sine, that's not going to take any time at all. What about the differential of 2e to the 3 sine x? Well, the differential of an exponential is always the exponential itself, but then multiplied by the differential of what's up there, and the differential of 3 sine x is 3 cos x. So it's going to be that multiplied by 3 cos x, and it's up to you whether you want to now write that, probably would here, as 6 cos x e to the 3 sine x, just for when I'm going to be putting it into my equation or my values for differential. So differential is given by what? It's given by u dv by dx plus v du by dx. So in this case, just subbing everything across, u dv is those two. So I'm going to tidy that up and tidy the order up to make that minus 2 sine x e to the 3 sine x. And then plus v du is plus these two multiplied together. And again, before you write it out, just give yourself a little bit of time to look at it, or rather these two multiplied together. But what I am looking at is I've got cos x and cos x there, so I'm going to call that cos squared x when I'm multiplying them together. So I get plus 6 cos squared x e to the 3 sine x. Now remember what we're doing. The whole point about getting f dash x was to then say we want turning points. So at turning points, f dash x equals 0, and so that means I'm going to get all of this thing equals 0. Just use the iPad to save myself a bit of time here. That equals 0. It's really, really important, guys, that you do write in little labels like this as you're going through in case you make a mistake. Try and get your quotient rule and your product rule in the same sort of format each time. You're less likely to make any mistakes as you're going through and doing this. So yeah, when we get down to this equation here, we can take e to the 3 sine x out as a factor. So e to the 3 sine x can come out as a factor here. And what am I going to be left with? I'm going to have minus 2 sine x plus 6 cos squared x equals 0. Then from exactly the same argument as before, e to the 3 sine x equals 0, oops, handwriting, is going to give me no solutions. So e to the 3 sine x equals 0, no solutions. Or 6 cos squared x minus 2 sine x equals 0. And then hopefully you remember cos squared is 1 minus sine squared, so I can tidy that up as being 6 1 minus sine squared x minus 2 sine x equals 0. And then multiplying that all out is going to give me 6 minus 6 sine squared x minus 2 sine x is equal to 0. And then just to make it look like the equation we had that we were looking for up here, okay, what I'm going to do is to tidy it up as much as I possibly can. So I'm going to say, let's do it in 2 steps actually. I'm going to say that's 6 sine squared x plus 2 sine x minus 6 equals 0. So I've taken it all over to the other side, and then I'm going to divide everything by 2 as well. So I'm actually going to end up with this being my equation, plus sine x minus 3 equals 0. And any variation of that in terms of any equivalent values to that, I've just used that because I'm going to want to factorize and solve it later on, or use a quadratic formula on it, and I'd rather have it in that format. So part B then, where a, b and c are integers to be found, we've done part B as well. Part C then says, can you actually find the x coordinate and give our answer to 3 decimal places, the x coordinate for Q. So when I solve my equation, I will have 2 values of x that are possibilities, and I'll have to take the bigger one when we've got the 2 answers. But let's go ahead and do that. So this is part C, solving this quadratic then. And that's simply going to be by sticking it into the quadratic formula. You've got a little bit of space there. So to stick it into the quadratic formula, we're going to say sine x is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. Well, that works out to be minus 1 plus or minus the square root of b squared minus 4ac then is going to be 1 minus 4, but times 3 times minus 3 all over 2a all over 6. Well, that tidies up to sine x equals minus 1 plus or minus root 37 over 6, which gives us sine x works out to be equal to, I'm just going to write it down to 3 decimal places, but obviously I'll have the whole values on the calculator, we get these two possibilities for what sine x works out to be. Well, the one on the right hand side is going to lead to no solutions. Sine can't be bigger or greater than -1, so that one's not going to give it to us. And if sine x equals 0.847, then x works out to be 1.01 or 2.131, and it's asked us for the x value to 3 decimal places, and from the graph we can see there's my first value, there's my second value. So to make it really clear to the examiner then, so x is equal to 2.131. Again, we can say from the graph, we can tell it's the second of the two values there. And so, yeah, that's a solution to the last part of it. And that finishes off quite a nice trig and differentiation question. Hopefully that all makes sense to everybody.